Ah, I missed. He's on my 6 and I can't see him. Should I move my hand to my mouse to see what he's doing but lose control, or do I stay on my controls and try to evade? What do I do? What do I do? What do I do? Come on, not again. This is a huge problem in dogfighting, because it can be really challenging to look at the enemy with a mouse while controlling the plane. Wouldn't it be great if I could just look around with my head? Well, I think I can do that, so here's the plan. I'm going to be in the center of a sphere that wraps around me. There are going to be some projectors to project the scene from the flight simulator onto the sphere for me to see it. However, the field of view of the projectors is quite small, so I would need a ton of projectors if I wanted to cover the whole sphere. Luckily, there's a workaround. I can place some spherical mirrors and move the projectors to reflect off them first, allowing projection onto much more of the sphere. I'm not the one who came up with this trick. A researcher named Paul Burke is, and he goes into way more detail about how spherical mirror projection works on his website, which you can check out in the description. Which brings us to our first problem, focusing the projectors themselves. I originally thought that reflecting off the spherical mirror would be like looking through a car's rearview mirror, where you have to look in the distance where you want to see instead of at the mirror itself. The reason that doesn't work here is because for it to be able to reflect sharp images to different distances, it would have to focus at different distances as well, which is impossible. So to solve this, you actually have to focus the projector onto the mirror itself. This allows the focused light from the projector to be reflected by the mirror so that it stays sharp onto the dome. Unfortunately, because of the limited space in my 8-foot diameter sphere, I don't have enough physical room to be able to put the projectors far enough back to focus onto the mirror. To fix this, I'm going to move the projectors under the spherical mirrors and rotate them outwards. Then I'm going to place some flat mirrors for them to reflect off of first. There isn't a problem with reflecting onto flat mirrors because the light is being reflected straight on instead of at an angle like the spherical mirrors were doing. And this brings us to our second problem, warping. Because the projection is reflected off of a non-flat surface, it will warp the image projected onto it as it reflects. So to fix this, we must pre-warp the images to make it look correct after the reflection. To determine how to warp the image, I'm going to use something called a ray tracer, but what exactly does that mean? Basically, a ray tracer is a simulation that bounces rays emitted by light sources around objects in a scene. These can be used to figure out how to warp the input images for the flight simulator. So, let's make one. Okay, so here's how it works. I've input images from the flight simulator that were taken 120 degrees apart to match the 3 projectors. I have the warp maps that can be used to warp those images from the flight simulator to make the scene look correct. And finally, I have the ray tracer to simulate what it would look like from inside the sphere. In real life, from inside the actual full motion flight simulator. And just to prove that this is in fact a ray tracer, here's a view with all of the rays, showing the actual paths that they take as they bounce around the objects in the scene. As a quick side note, you may have noticed that there's a black triangle on top of the sphere. This is because I'm using 120 degree field of view images from the flight simulator, so when the projection is aimed horizontally, like it was here, it only shows 60 degrees up and 60 degrees down, leaving no projection on the top and bottom. This can be fixed by rotating the projection up by 30 degrees. However, it makes the unprojected section on the bottom of the sphere larger, because doing that removes 30 degrees from the bottom of the projection. This is an adequate solution because we don't normally need to look below the cockpit while flying. But what flight simulator is this? For this project, I'm going to be using the FlightGear flight simulator, which is a free open source flight simulator that I can change the code of and basically make it do whatever I need it to. Now that we've got that out of the way, we're getting pretty close, but there's still one more really big problem to figure out, warping FlightGear itself. Right now, we can only warp still images, so if I want FlightGear to be able to render onto the sphere in real time, I need it to automatically warp as it renders. To do this, I will have to change the source code, so I made FlightGear warp the same way that the ray tracer has warped the still images, and here's the result. It cleanly warps at 20 frames per second, with 1920 by 1080 windows for each projector, and with a more powerful computer, I'm sure that it could get past 40 or 60 FPS. Now that all of the projection simulations are out of the way, if I want to make this full motion flight simulator a reality, it has to be physical. So, to make the 8-foot diameter sphere that I've been talking about, I designed a shape in OpenSCAD that can be cut out of plywood on a CNC router and slotted together. This shape is 1/16 of a sphere, so we make 16 of them and connect them together with magnets. The cool thing about being designed in OpenSCAD is that the design is fully parametric, so I can adjust all the values for the design independently down to the smallest detail. If anyone watching this video owns a CNC router and wants to help me with this project, please reach out in the comments, that'd be amazing. Now, for the full motion part, I plan to take inspiration from the multi-axis trainer, but the difference is there might only be one movable ring because I don't need yaw for my full motion flight simulator, only pitch and roll, though I might add it someday. So, to sum up what I have to do from here to finish the project, I need to build the sphere, test projection in real life, design and build a cockpit that replicates the one in FlightGear, get full motion working, and fix any other problems that might come up along the way. That will come in part 2 of this video, so stay tuned. If you want to fly the F-22 that I've been showing in this video on your own, I've put links to both it and FlightGear in the description so you can go check them out and fly it. You can also find a link to the GitHub of the ray tracer down there as well. That pretty much sums up what I've been doing since my project to contact the ISS using my own homemade equipment, so if you like videos like this, please consider subscribing and make sure to hit that notification button so you don't miss out on any new videos. If you've made it this far, you've earned a cinematic. Enjoy!